Okay, starting with number 7, if you have a coefficient of 1 in front of the x squared, it is 1 go. So go ahead and give me 2 sets of parentheses. The first one will always be the x. And then we have to decide on what 2 numbers can we multiply, get to negative 36, and add to get 5. 9 and negative 4. So we got 9 and negative 4. Do we agree on that? Yep, and that's it. Voila. Now for number 12, though, it doesn't have the 1 in front of the x squared. This might be the wrong class, right? All right, let's go to number 9. Number 9, we have difference of 2 squares. So the way I want you to write this is the following. Chunk squared minus chunk squared. The first one was already squared form. The second one, what number must go in the inside? 3. So what that means is, these 2 numbers are all that we need for our difference of 2 squares, which is going to give us one's a minus, one's a plus, in any order. And just copy those 2 pieces, and we are done. Questions on that one? Is there something called a sum of squares in algebra? Nope. It's only difference of 2 squares, and that's it. If you see a sum, it's going to be imaginary at some point, so it's not going to work out. For number 12, what is hindering my shortcut? There's a 2 in front of the x squared. So we're going to use grouping. And if y'all remember, we multiply a and c, which is 2 times negative 3 is negative 6. And then your middle number goes on the bottom. Some of you guys maybe use a t-chart. For me, I like this the best. All right. What 2 numbers would satisfy the product on top, sum on the bottom? Negative 1 and negative 6? And positive 6, correct? So the rule is we keep the first term, we keep the last term, and we split the middle with the 2 values. So minus 1x plus 6x. And the middle has to have an x because 5x is the middle term, has an x. So let's go ahead and group them into sets of 2s. From my first set, what is common between those 2? Ooh, 2 and an x? Just an x. So I have remaining 2x minus the 1. Are we good with that one? This right here always takes over, so plus. For my second group, what is common? 3. And when I take that out, we get 2x minus 1, and that's always a good self-check when they're identical. So our final factor is x plus 3, 2x minus 1, and boom, done. Yes, ma'am.
Before we go to the back,
Mm-hmm.
can you do number 17 or 18 on the section 3?
Section 3.
Yeah.
We're doing 18.
Okay.
Uh-huh. Do you also want 17?
Yes.
We could do 17, yeah. Did the screen like kind of do something just now? Did y'all see it like blink a little bit? It's going with the weather. It's storming right here. All right, on number 17, is this difference of 2 squares? So let's write out chunk squared minus chunk squared. We know the second chunk has to be 9. What must go in the inside of the first one? X squared. So then let's circle the pieces. Let's go into control our difference of 2 squares. So when I do, I get something on the minus, something on the plus. Switch them if you want. So what I have circled, we're going to copy as it is. And something unique is going to happen. I did mention a while ago there's no sum of 2 squares, right? This is done. But that is not done. So how I can rewrite this one will be 3 all squared. And then we can further split the first set, which is going to give us x minus 3, x plus 3. Ooh. And then we keep the last chunk, which is not difference of 2 squared as it is. And that's our final answer. So if you can go on further, please do. Yes?
Why don't you say that's the number?
There, it's not a thing. Mm-hmm. And if you want to know, I can kind of explain. Yes or no? Yeah? Say it?
Yes.
Okay. So imagine x squared minus or plus 9 equal to 0. If I subtract 9 on both sides, we get x squared equals negative 9, right?
Yes.
When I square root on both sides, can you square root a negative number? Is it imaginary? All right, let's go on to number 18. On number 18, would this be a shortcut? Huh. You're like, I don't like this right here.
Wait.
Okay, y'all ready? I'm gonna use some pre-calc concept. Let u equal x squared. I don't know, I'm just letting it, whatever variable you want. So that means this one in terms of u is gonna be u squared minus 13u plus 36. Now does that sound familiar? Something squared, something with the one variable and a constant. Can this be a one-go shortcut? Yep. So what is going to satisfy the 36 as a product and negative 13 as our sum? Negative 9, negative 4. Do we agree on that? So negative 9, negative 4. But then our question was not in terms of u, so let's plug this back in into our u. So we get x squared minus 9. Oh, something weird. We can go on further, right? And then we have x squared minus 4. Can I go on further right here? Yes. So we have difference of two squares on two different ones. So the first one we've already done, x minus 3, x plus 3. What is the factor of the next one? X minus 2 and x plus 2. All right, so let's go on to the back. Should be a lot of reminders from last year. Okay, on the bottom. Okay, on number 18, do we see that it's already in a grouping form? Is it pretty much set up for us? Yep. So all we need to do is take this one and take this one. And when I do, I know the common term that I could take out is x cubed. So I have x plus 1. Somebody is talking over me. I feel very important. What can I take out on the next one? The negative 4. So when I do, I'm anticipating it to be exactly the same as the other parentheses. Is it? So our final answer is x cubed minus 4, x plus 1. Now, is the first one difference of two squares?
Yeah.
Ooh. Cubed? Cubed? No. So we're done.
Could it be like x to the 1.5?
X to the 1, don't go there.
Okay.
Don't do that. Delete it, it never happened. Okay. On number 19, is this difference of two squares?
Yes.
So let's go ahead and write it as a chunk squared minus chunk squared. So 16 can be written as what? 4 and the x. What about 9y squared? 3y. So all of that we're going to take. So when I do, we get 4x minus 3y and 4x plus 3y. Boom, done. Oh man, do I have room for number 20 somewhere? Ooh, move it down. You know, it's fine though, because look, isn't that already written as chunk squared? Oh, so let's see if I can fit all this. It's going to be a plus b minus all that, 3a minus 2b. And then it's going to be a plus b again, but this time plus 3a minus 2b. Now, I made a mistake on purpose.
Yeah, when you distribute the minus to the
So when I said minus right here, this minus was going to go to all the component. So should this be a positive? So if you want to write that in parentheses and then distribute, go for it. But I kind of want to do two things at the same time. So then let's combine like terms. What can I combine right here? So it'll be negative how many a? 2a. How many b? 3b. How about on the next one? What can I combine? How many a? 4a minus b. That's right, 1b, and we are done. Okay, not bad. I guess it kind of fit. For 21, is this, could I write this as a difference of 2 squared possibly?
It's just x minus y, x minus y, x minus y, and do that like 8 times.
Do it 8 times?
Or like x minus y times x plus y. And do
We're going to stop making up math. Stop it. All right. So here's what I want you to do. Chunk squared minus chunk squared. To make that happen, what do I need for the x's? X to the power 4 and y to the power 4. So that means these two are going to carry with the plus or minus. So we have, oh, do I have room? I don't know. Plus, there you go. Which piece can I not further go on? The one with the plus. There's no sum of squares. I mean, I almost said the wrong thing. Can I further go on for this one though?
Yes.
So I could write that as x squared minus y squared, x squared plus y squared. And then we're gonna leave the last part alone. It's just gonna tag along. Uh-oh. You know, I did it. Now, are we done though? No. Can I go on further right here?
Yes.
So we have x minus the y, x plus the y, and let's copy everything at the end.
It's broken down to this.
And done.